Your server is online, the network cable is connected, the switch is working, but suddenly the server can't reach anything outside its own subnet. So what happened? The default gateway failed, and when the gateway goes down, the server may become isolated, even though the server itself is completely healthy. That's why data centers use First-Hop Redundancy protocols. They keep the default gateway available, even when a router or layer 3 switch fails. Let's keep this simple. A server normally uses one default gateway to reach other networks, but relying on one physical gateway creates a single point of failure. First-hop redundancy solves this problem by using two or more layer 3 devices together. To the server, they look like one gateway. Behind the scenes, one device forwards the traffic and another device is ready to take over. Imagine this server has the default gateway 192.168.10.1. Everything works normally until that gateway device fails. The server can still communicate with devices inside its own subnet, but it can't reach another VLAN, the internet, storage networks, or external services. And here's the important part. The server usually doesn't automatically discover another gateway. So even if a second router is available, the server doesn't know how to use it. That is the problem first-hop redundancy solves. Instead of configuring the server with the address of a physical switch, we give it a virtual gateway IP. For example, the two layer 3 switches may have their own addresses. Switch A uses .2, switch B uses .3, but the servers use .1 as their default gateway. That .1 address is virtual. One switch currently owns it and forwards the traffic. If that switch fails, the other switch takes over the same virtual gateway. From the server's point of view, nothing changed. It continues sending traffic to the same IP address and virtual MAC address. The first protocol is HSRP, or Hot Standby Router Protocol. HSRP is a Cisco protocol. One device becomes active. That device handles the gateway traffic. The second device becomes standby. It switches the active device by listening for hello messages. If the active device stops responding, the standby device takes over the virtual IP and virtual MAC address. The failover happens automatically and the servers continue using the same default gateway. Next we have VRRP, or Virtual Router Redundancy Protocol. The idea is very similar to HSRP. Multiple devices share one virtual gateway address. One device acts as the primary gateway. The others remain available as backups. If the primary fails, the backup with the highest priority takes over. The main difference is that VRRP is standard-based, so it can be used in multi-vendor environments. Now let's look at GLBP, or Gateway Load Balancing Protocol. HSRP and VRRP mainly focus on redundancy. Normally one device forwards traffic while another waits. GLBP takes a different approach. It can allow multiple gateway devices to actively forward traffic at the same time. Different servers can be directed toward different physical gateways while still using one virtual gateway IP. So GLBP provides both gateway redundancy and load balancing. So which one should you use? Use HSRP when you're working in a Cisco environment and want a simple active and standby design. Use VRRP when you need a standards-based solution, especially in a network with equipment from different vendors. Use GLBP when you want both redundancy and gateway load balancing. All three protocols solve the same basic problem. They prevent the default gateway from becoming a single point of failure. So, here's the key takeaway. Your servers may be online, but without a working default gateway, they can still lose access to the rest of the network. First-Hop Redundancy protocols solve that problem. HSRP gives you Cisco active and standby redundancy. VRRP gives you a standard-based alternative. And GLBP adds load balancing to the design. In the next episode, we'll look at port channel and VPCs. We'll see how multiple physical links can work together to provide more bandwidth and redundancy. Thank you for watching.